A new high-performance field reversed configuration operating resume in the C2 device. Number 3. And Plasmagun. A Plasmagun and two magnetic fields and plug are added to the C2 device. As sketched in Figure 1, the Plasmagun is located on axis at Z equal minus 8 meter inside the south diverter. The two end plugs up to 2 Tesla pulsed magnetic field are located at Z equal plus minus 7.3 meter between the formation regions and the diverters. The Plasmagun and the end plugs have many potential benefits, such as improved FRC formation, edge layer confinement, particle refueling, stability through line trying to the gun, neutral gas control, radial electric field control of the FRC rotation, and creation of EXB velocity share. Some of these benefits require a cold and dense plasma stream, while others require a hot tenuous plasma stream. The AMBAL Plasmagun is capable to produce either hot or cold plasma. The C2 AMBAL Plasmagun, obtained from the Badka Institute of Nuclear Physics, is sketched in Figure 2. An annular 0.11 meter inner diameter and 0.13 meter outer diameter plasma stream to 10 to the 22 power d per s 4 to 6 milliseconds is created with two gas bulbs and an anode to cathode voltage dropped to 0.5 kV. The gun arc current is to 10 kA. The gun magnet provides an axial magnetic field to 0.5 Tesla. For all data in this paper, the gun produces a hot T to 30 to 50 electron volt and T to 100 electron volt. Tenuous, smaller than 10 to the 90 power meter minus cube plasma stream. These plasma parameters are estimated from diamagnetism just in front of the gun, Z to minus 8 meter, and in the formation quartz tube, Z to minus 6 meter, and from Langmuir probes and microwave interferometry, Z to minus 7 meter. The gun also creates an inward electric field in the plasma stream. The radial profiles to prove floating potential, as shown in Figure 3, at Z equal minus 7 meter for the gun alone and in the FRC edge layer at Z equals 0, and and at t equals 0.3 milliseconds. These triple probe data are accurate shot by shot, and typical standard deviations are indicated. Figure 3 suggests that the radial electric field of the FRC edge layer is inward with the plasma. Plasmagun and outward without it. These trends are only qualitative because floating rather than plasma potentials, as shown in Figure 3, prove measurements become increasingly difficult close to the FRC separatrix, and no data are available for R smaller than 0.4 meter. The gun establishes a good electric communication along field lines through the entire C2 device. As illustrated in Figure 4, the potential of a floating electrode located on axial at Z to 10 meter arrow trace of Plasmagun on state tracks the potential of the gun floating electrode at Z equals minus 8 meter upper trace of Plasmagun on state for the 6 milliseconds duration of the plasma stream. The potential are around minus 0.5 kilovolt, consistent with these measured in Figure 3. The Plasmagun inward electric field counters the usual FRC spin up and stabilizes the N equal to rotational mode, as illustrated in Figure 5 side on CO2 interferometry data at Z equals 0 are compared without the Plasmagun and with the Plasmagun. These data are taken without NB injection after FRC formation and without quadrupoles Q equals 0. The discharge in Figure 5 shows easily recognizable N equal 2 mode signatures between 0.3 and 0.8 meters. The FRC elliptical deformation saturates with a ratio of major or minor axis to 2 as estimated from interferometry maximum to maximum amplitude and from barometer array reconstruction. The discharge in Figure 5 shows no N equal to oscillations up to about 0.9 milliseconds. The FRC disrupts around that time. The show oscillation in Figure 5 between 0.4 and 0.8 milliseconds is an N equal 1 wobble minor probes and barometers arrays indicate that this n equal 1 mode has a long wavelength. Similar displacement along the FRC length and rotates in the electron diamagnetic direction with a relatively small amplitude. This is illustrated in Figure 6 with two C2 discharges without and with the plasma gun. No quad poles Q equals 0 are used in both cases. The trajectory of the FRC center is plotted as a function of time, as estimated from two orthogonal barometer arrays. Without the plasma gun, the n equal 1 mode rotates first in the ion diamagnetic direction, red trace, before reversing in the electron diamagnetic direction, blue trace. The mode amplitude increases with time. With the plasma gun, the mode rotates in the electron diamagnetic direction, blue trace, at all times with a relatively small 5 to 10 centimeter amplitude. Thank you.